All right, welcome back to Mr. PL's with Algebra 2. This is Unit 3, Topic 1, SLT number 3. We're going to be finding sine and cosine values of any angle using a reference angle. So a lot of reference angle stuff in here, and we're also going to get into how to find reference angles using sort of like a cheat sheet for figuring out whether or not it's positive or negative. So there's a lot of things that we're going to be doing here. What is the angle of rotation for point C? First thing I need to do is I need to figure out how many different equal parts there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I know it's 360 degrees in a circle. Divide that by 16. It tells you that each one is 22.5. If that's 22.5 and that's also 22.5, then you know that this is a 45 degree angle. So that's two 22.5s being added together. What other point is the same height as point C? That's pretty easy. That's G, because B is the same as H, and then G is the same as C. And then F is the same as D, and E is in the middle. What is the angle of rotation from the start? That is corresponding point. So if it's corresponding point to C, oh, I wrote C, of course I did. C is the same as G. So what is the angle measure of G is what we want to know next. Well, if this is a 45 degree angle, and we know this is a 180 degree angle, then this angle right here would also be 45 degrees, less than 180 degrees. So 180 minus the 45 degrees gives us 135 degrees. There's your answer. Because anything that's in this quadrant is always going to be 180 minus the reference angle. Anything that's here is always theta. Anything that's here is always going to be 180 plus theta. And anything that's here is going to be 360 minus theta. And when I say here, I'm splitting it up into 4 quadrants. If it's in quadrant 1, it's just the reference angle. If it's in quadrant 2, it's this, because it's going to be 180 take away whatever that reference angle is. This is going to be 180 plus the reference angle, and this is going to be 360 minus the reference angle. So it really just depends which quadrant that you're in. Look at any circle with the center of the origin. So this is the formula for a circle. So we have 8, 6. We also know that negative 8, 6 would also be the same height. So negative 8, 6 would be right here. Draw the corresponding right triangles for them. So that would be this triangle here and this triangle here. Once I know theta, then I know this one's 180 minus theta. Okay, next, moving on. So we have 3, 4. Then we also know that negative 3, 4 would also be exactly the same height. So first thing I need to do is figure out the hypotenuse. Now, this triangle right here means that this has gone right 3 and up 4. So I need to figure out the hypotenuse because that's the radius of the circle. And we can't figure out the height without the radius, as we've done in the past. So I'm going to use Pythagorean theorem. I'm not going to do that every single time because you really should just kind of know your triplets. So that's going to be 3 squared plus 4 squared equals the radius squared. 3 squared is 9 plus 16 is 25. Square root of 25 is 5. So now we can do this. So sine of theta, so this is theta, so that's opposite over hypotenuse, that's 4 over 5. And cosine of theta is adjacent over hypotenuse, which is 3 over 5. So there's 2 ways you can now solve for theta, and they should give you the exact same answer. So I can either do inverse sine of 4 over 5, or I can do inverse cosine of 3 over 5, and they should give you the same answer. So inverse sine would be second sine. It should give you a little sine with an inverse symbol, which means I'm just trying to do the inverse to get rid of the word sine. I'm doing just like you would solve any equation, you do the opposite operation in order to get rid of something. So inverse sine of 4 divided by 5, enter, and you get about 53.1 degrees. Now, if you do inverse cosine of 3/5, you should get the exact same degrees because it is the same reference angle, so it should not be any different. Same thing goes for this one. First thing I'm going to do is I'm going to make my triangle. This is negative 8. This is 15. So let's ignore the negative for a second to figure out this hypotenuse because the radius is always going to be a positive number. So that's 8 squared plus 15 squared equals the radius squared. Well, you know 8 squared is 64, and if you add 225 to it, you get 289, and the square root of 289 happens to be 17. Now, this is just one of those things you should just know triplets. 8, 15, 17 is a right triangle. All these are going to be perfect right triangles. There's only like 4 or 5 that you ever usually see. I know there's an infinite amount of them, but there's only a few that you'll ever really see, and 3, 4, 5 is definitely the most common one. Sine is opposite of hypotenuse, 15 over 17. Cosine is adjacent over hypotenuse. Now, keep in mind, I'm going to use a negative here. because cosine of a negative number is going to give you that same degree, and we'll kind of get into that later on, how sine of a positive and cosine of a negative can be the exact same thing. So cosine, so I'm going to do cosine this time. So second cosine of negative 8 divided by 17 and parenthesis. Okay, so it's not going to be able to give it to me. Okay, so I'm going to go ahead and use sine. So inverse sine, I forgot about that, 15 divided by 17, or I could have just left off the negative. I believe the calculator gives you the exact same answer. 61.9 degrees. And there we go. All right, so moving on. So we got two more examples of the exact same thing. So I'm going to do just this one because for the sake of taking time. So this one, the reason why I want to do this one is because it's going more than 180 degrees. So this triangle here, so this is negative 12 and this is negative 5, and we're trying to find this radius. So first of all, 5 and 12, so that's 25 plus 144 equals the radius square. Add those two up, you get 169, and the square root of 169 should be 13. So I know this is 13. 5, 12, 13 is probably the second most common of the triplets, in my opinion at least. Sine of theta. So if this is theta, so remember we're just using this right here. Okay, we're using theta. Sorry, this theta right here. So since it's negatives, so sine of theta would be opposite over hypotenuse. So that's negative 5 over 13. Whereas cosine is going to be adjacent over 13. So inverse sine of negative 5 divided by 13, and that gives me negative 22.61. So that means this is being subtracted by 22.61. Okay, so let me do the other one. So inverse cosine of negative 12 divided by 13. Okay, so I guess I'm supposed to not use the negative, so cosine of 12 divided by 13, enter. Okay, so I'm getting 22.61, so that tells me that this is 22.61. So I guess it didn't matter if I used a positive or a negative. Now it just gives me a negative, just kind of have to ignore it in that case. So 22.61 is this angle right here. So this is 180 plus 22.61. Plus 22.61, and that gives me 202.61 degrees. All right, so the last thing I wanted to cover, I think I've covered this fairly well. Okay, maybe not, so let me go over this. First, find the radius like we've done before. This is basically just what we have been doing. Whenever we're finding the radius, whenever we're finding the sine of a ratio, sine is always opposite over hypotenuse. It's using the x-coordinate. Okay, so let me think that again. So this is sine. So sine is always opposite over hypotenuse. So it's always going to be the height, which is the y over the hypotenuse. And cosine is always going to be x over the hypotenuse. So that's what we're going to be using in the future. Instead of using... we're going to use y over r and x over r instead of opposite over hypotenuse. So this is pretty much the end of us using those terms for SOHCAHTOA. So in this case, the radius is what? Okay, so if this is 0, negative 8, so then we know the radius is 8. That's a pretty easy one because it's going straight down, which means the sine is going to be y over r. So y would be negative 8 over a radius, which is 8. Cosine, which would be 0 over a hypotenuse of 8. So what is theta? So theta in this case should be 270 degrees, and we know that. I can go ahead and do the inverse of inverse cosine of 0 divided by 8, and that gives me 90 degrees. That makes sense that this would be 90 degrees because 180 plus 90 makes 270 degrees. This radius over here, so if, I'm going to actually calculate this one out. So if this is negative 6 and this is negative 8, so that's 36 plus 64 is 100. Square root of that equals 10. So I know this is going to be 10. This is a 3, 4, 5 triangle. So the radius is 10. So sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse. And if I solve either one of these out, so inverse sine of negative 8 divided by 10, that's going to give me 53 degrees. So that's right there. So 180 plus 53.1 gives me 233.1 degrees is your answer. Okay, so yeah, that's a lot more covered in this video than I had originally mentioned. This last thing I want to talk about is how to determine if it's going to be a positive or a negative using this this picture right here is the one that I'm going to use the most. So this is the idea that it's all students take calculus, or you might have heard other, what do you call these? I forgot what they are. So, things that stand for it. So all students take calculus means that all of them are going to be positive in the first quadrant. Only sine is positive in the second quadrant. Only tangent is positive in the third quadrant. And only cosine is positive in the fourth quadrant. So it's all students take calculus. It tells you which one's going to be positive in which quadrant. So what you do is, and I'm not going to do all of these, so sine of 50, so you look at the sine, 150 degrees will be somewhere around here because this is 90 degrees, so you know it's going to be positive. Cosine of 50 degrees would also be in the first quadrant. It's going to be positive. Well, everything in the first quadrant is going to be positive, like I said. 220 degrees is more than 180. So you know when you're in the third quadrant. The only one that's positive in the third quadrant is tangent. The other two are negative. If you're in 115 degrees, you know you're in the second quadrant because it's less than 180, but also more than 90. And the only one that's positive is sine. Sine is the only one that's positive. The other ones are negative. All right, so I think I'm going to stop it right there. Thanks again for watching, and please look forward to future videos. Have a great day.